So Meshcapade is a spin-off from Max Planck Institute, kinds of industries that present at 3D Body Tech by now. It's constantly changing and is growing, especially the physical reality of us, of real people, and being able to bridge that to be able to bring it into the digital world. How we see or perceive what a human is through different means, just body measurements. Or, of course, there's 3D scans. There can be different kinds of sensors and different kinds of technologies perceive the world and especially humans in different ways. There's photos, motion capture. There's even voice that can be used. We're encoding everything into one simple format so that whether your data is body measurements or if it's 3D scan, you can, or images or videos, motion capture, or just text, you can create realistic humans in motion with nuanced animation, defining the simple model, the SMPL model, as essentially just a way to encode the information of the reality of ourselves and be able to put it into a digital format that can be used across dimensions, across platforms and different applications. We intentionally called this model simple because we wanted it to be really easy for use across graphics, but also for AI. It's a parametric model of humans in 3D. What does that mean? That means it's extremely compact. So all of these bodies that you see here, they're actually represented with just 300, something around 300 numbers. That's like less than 3 kilobytes. How big is a 3D scan file? It can be 100 megabytes or 500 megabytes. Can be even higher resolutions, can be even bigger. It's trained on about 1 million 3D scans of people of various body shapes. And then there were many 3D scans and now even 4D scans. Actually, the 3DMD scanning system that we have at Max Planck is heavily used just for generating lots and lots of training data. That this model, the way we trained it from this training data, we turned all of that scan data into a super simple equation. We wanted to make sure that it is compatible with standard 3D graphics. So it is built with a template mesh where we added the joint location. Here what you see is for different body shapes, the joints, where the joints should update, and then once you've created a specific body shape, how the pose corrective blend shapes should be applied so that you can see musculature and soft tissue deformation during motion. The input is simply some new data. It can be a 3D scan, be motion capture or an image, and the equation that you're using here is it's just a process to update these 300 numbers of the model so that the pink body is able to match up to the blue one, and that is just minimizing the distance between these two objects in 3D. And that's it. Everything was fully compatible with standard representations so that it would work with 3D graphics engines, cloth simulation programs, and also is the AI component, like I showed you, being able to put it into optimization methods like optimization processes. This simple model as the representation of what a human looks like, you can connect it to language and train language models to be able to represent humans from just text. Unifying all of these different components, unifying the power to make it available to the masses. Whether you're working, your needs are around body shape accuracy, or if we want to get towards more realism, you can transmit and generate your data in this core format and then go towards realism or stylization layers on top or get accurate motion.